Most people think oxygen is simple. You breathe in air, your lungs absorb oxygen, and the blood carries that oxygen through your body. Then your cells use it for energy. End of story. And if you check your oxygen levels in a pulse oximeter, you'll see something like maybe 97, 98%. That number looks reassuring, and most people assume it means their body is getting all the oxygen it needs. But here's the strange reality. You can have a completely normal oxygen level in your blood and still have tissues in your body that are effectively starving for oxygen. When that happens, the symptoms can show up in ways that feel confusing, frustrating, and often invisible to traditional tests. Fatigue that doesn't improve with rest, we're talking brain fog that makes it hard to think clearly, inflammation that seems to linger no matter what you try, a body that struggles to recover from exercise, from stress, and from illness. And if you're experiencing something like that, you know how unsettling it can be when your labs look mostly normal, but you still feel like something is clearly wrong. So how can you tell that your cells might be short on oxygen if your oxygen levels look normal? To understand that, we need to talk about how oxygen actually works inside the body. Because oxygen is not about breathing. Oxygen is about energy. Every cell in your body depends on a constant supply of energy in order to function properly. Your brain requires energy just to think clearly. Your immune system requires energy to fight infections. Your liver requires energy to detoxify waste products. Your muscles, they require energy as well to move. And all that energy is produced inside your cells in this tiny structure called mitochondria. You may have heard of the mitochondria described as the power plants of the cells. That description is actually pretty accurate. Mitochondria produce molecules called APT, which acts like a fuel that powers nearly every biological process in the body. So without ATP, your cells cannot repair themselves, detoxification slows down, the immune system struggles to regulate inflammation, and your brain begins to lose mental clarity. So when ATP production falls, the entire system starts to struggle. Now here's the key point. Mitochondria cannot produce ATP effectively without oxygen. Oxygen is the final ingredient in this metabolic process that converts fuel into usable energy. So without sufficient oxygen reaching your mitochondria, ATP production drops dramatically. And when ATP production drops, symptoms begin to appear. We're talking fatigue increasing, brain fog, your recovery slows down, and inflammation becomes harder for the body to regulate. But here's where the story becomes more complicated. Most people assume that oxygen problems only happen when someone cannot breathe well or have lung disease. But the truth is that oxygen delivery involves much more than just breathing. It depends heavily on your circulation, but more specifically, something called microcirculation. Most people think of circulation in terms of the heart pumping blood through the arteries and veins, but most important part of the entire circulatory system happens in the smallest vessels in your body. These tiny vessels called capillaries. Capillaries are extremely small. In fact, they are so narrow that red blood cells often have to pass through them one at a time in a single file line. These vessels form an enormous network that reaches every tissue in your body. And this is where the real exchange happens. Capillaries are where oxygen leaves the bloodstream and enters the tissues. They're where the nutrients are delivered to the cells and where the metabolic waste is picked up and carried away. This tiny network of vessels is known as microcirculation, and it plays a critical role in determining how much oxygen actually reaches your cells. Here's something most people don't realize. Blood oxygen level does not necessarily mean your oxygen is getting delivered to your tissues. It only tells you how much oxygen is present in your blood. If your microcirculation is impaired, oxygen may not reach the cells efficiently even when the blood oxygen levels appear normal. Imagine a city where the highways are completely clear. Traffic flows smoothly on the main roads. From above, everything looks fine. But when the cars exit the highway and try to enter the neighborhood streets, they encounter roadblocks. Side streets are closed. Traffic becomes congested, cars cannot reach their final destination. From a distance, the system looks great, but at the local level, movement has slowed dramatically. Something very similar is happening inside the body. Blood oxygen levels look healthy, but oxygen delivery to tissues can still be impaired. And when that happens, mitochondria cannot produce the energy they need. And when that happens, mitochondria cannot produce energy efficiently. Now let's talk about what can disrupt microcirculation. One of the biggest factors is actually inflammation. Inflammation can damage the delicate lining of our blood vessels. The lining is called endothelium. These endothelium play a crucial role in regulating blood flow. It controls how the blood vessels expand and contract, it helps maintain smooth circulation, and it allows oxygen to move efficiently into the tissues. So when the endothelium become inflamed or they're damaged, the blood vessels lose that flexibility and circulation becomes less efficient. In a nutshell, microcirculation just slows down and oxygen delivery begins to decline. This is one of the reasons infections can create long-lasting symptoms. We're talking infections like Lyme disease and COVID that are known to affect our vascular system. They trigger inflammation in the blood vessels. They disrupt these endothelial cells from functioning, and they increase clotting tendencies and oxidative stress. So over time, these changes can impair our circulation. And when microcirculation becomes impaired, oxygen delivery suffers. Of course, when your oxygen delivery suffers, your mitochondrial energy production declines, your cells are trying to run on less oxygen, your ATP production drops, your metabolism becomes inefficient, and symptoms begin to appear. Fatigue, it becomes persistent. Mental clarity starts declining. Exercise tolerance, it drops. And of course, recovery slows. Now here's another important factor to enter the picture: detoxification. The body is constantly clearing metabolic waste and inflammatory debris. The liver processes toxins, the kidney filters out the waste, the lymphatic system helps transport and remove unwanted material, but all of these systems require one thing: energy. ATP powers detoxification pathways too. So when ATP production drops, detoxification becomes less efficient. Waste products accumulate, inflammatory signals increase, even oxidative stress rises, and those factors further impair circulation and mitochondrial function. At this point, the body can get trapped in this vicious doom loop. Reduced oxygen delivery lowers ATP production, lower ATP production slows detoxification, slower detoxification increases inflammation, and then inflammation further damages the circulation. The cycle repeats over and over. This is one reason chronic illness can feel so frustrating. People often try to treat and address the individual symptoms, but if the underlying energy bottlenecks remain unresolved, progress can be slow. Now, before we go any further, I want to pause for a moment, because if this framework is making sense to you, there's a resource that goes deeper in how oxygen and cellular energy interact. We created the guide, The Synergistic Power of EWOT and Red Light Therapy. In that guide, we explain how oxygen delivery and light-based mitochondrial stimulation can work together to support cellular energy production. It explores the biology behind these two approaches and their interaction with circulation, mitochondrial signaling, and recovery. If you want to understand how the oxygen and red light influence cellular energy systems, that guide can connect many of the concepts we're discussing here. Now let's continue to explore the oxygen story, because there's another clue that oxygen delivery may be impaired in the body. That's exercise intolerance. Many people dealing with chronic illness notice something strange. Exercise does not make them feel better, it makes them feel worse. They push themselves to move more, they try to rebuild strength, and instead of feeling energized afterwards, they completely crash. Their fatigue intensifies, their brain fog worsens, recovery takes much longer than expected. Why would exercise cause that response? Because exercise increases the energy demand throughout the body. Muscles require more ATP. Circulation must increase. Oxygen demand rises. If the system is already struggling to deliver oxygen efficiently, that increased demand exposes weakness in the system. The cells simply cannot produce enough energy to keep up. It's like asking an underpowered engine to suddenly climb a steep hill. The engine sputters, the system stalls. The same thing can happen inside your body when mitochondrial energy production cannot keep pace with demand. Now let's talk about the brain. Your brain consumes a remarkable amount of oxygen. Even though it represents only a small percentage of your body weight, it consumes roughly 20% of your oxygen supply. When oxygen delivery drops, the brain is the first to feel it. That's why brain fog is such a common symptom when cellular energy production is impaired. Neurons require ATP to transmit signals, memory formation requires ATP, attention and focus requires ATP, so without enough energy, neural communication has to slow down, and the result is cognitive sluggishness. It's difficulty concentrating, it's difficulty recalling words, that mental fatigue, brain fog. The brain's not broken, it's just underpowered. Now here's the encouraging part. When oxygen delivery improves and mitochondrial function begins to recover, many people notice improvements. Because energy production increases, circulation becomes more efficient, and recovery improves. So your inflammation becomes easier for the body to regulate. Understanding oxygen delivery provides a framework for explaining why so many chronic illness symptoms cluster together. We're talking brain fog, fatigue, exercise intolerance, slow recovery. These things are not random. They're signals that the body's energy system is struggling. And once you begin to look at the chronic illness through the lens of oxygen delivery and cellular energy production, something interesting happens. Symptoms that once seemed mysterious begin to make a lot more sense. But there's one more piece of the puzzle we need to explore. Because when people say they're tired all the time, the problem isn't a simple fatigue. In many cases, the brain itself is struggling to maintain energy balance. And when the brain begins to operate in a low energy state, it can send signals throughout the body that influence fatigue, motivation, and resilience. That's why this next video is so important, because if you want to understand why constant fatigue can sometimes be driven by what's happening inside the brain itself, you need to watch this next video. It's called Tired All the Time? Your brain might be trying to tell you something. And once you understand what the brain is doing in that state, the entire fatigue puzzle starts to look very different. Thank you.